Hello everyone, I welcome you to this Max lecture series. In this video, we are going to see rank of a matrix by using row-echelon form. This is a video by See-Through Max. Methods to find rank of a given matrix. If a matrix is given, then we can able to find the rank of the matrix with the help of minors. Another method, with the help of echelon form. If you convert the matrix into row echelon form or column echelon form, from this one also we can able to find rank of a matrix. In our earlier lecture, we have studied how to find echelon form. What is an echelon form? Even though we have already studied, a simple description about the echelon form is given here. Rows of zeros, if present, are the last rows. So the left hand side matrix has been transformed into the right hand side matrix with the help of elementary row operation. So in the left hand side, row 4, it is transformed to row 5 in the right hand side matrix. The same way, other matrices also transformed in such a way that each non-zero row, the leftmost non-zero entry is farther to the right in the previous row. To know more about this one and some solved examples, you can follow the pin. How to connect echelon form and rank of a matrix. The given matrix, if we can able to convert into an echelon form, then we can easily find the rank of a matrix. We have already studied the rank of a matrix is nothing but a number of linearly independent vectors, either row vector or column vector. So here it is, if a matrix is represented in row echelon form, then the rank of the matrix is the number of non-zero rows in the echelon form. That means, first we convert the given matrix into echelon form. For example, here it is row echelon form. Then we calculate the number of non-zero rows. That gives the rank of the given matrix. The same way we can do for column echelon form also. The help of column echelon form, we can able to calculate the rank of the matrix. We will solve a problem. Find the rank of the following matrices. In this problem, here directly the matrices are given in echelon form. So directly we want to find the rank. So A is a 3 cross 3 matrix. So already we have studied, if A is a 3 cross 3 matrix, then the maximum rank may be 3 only. That means it cannot be more than 3. So this is in echelon form. Okay. In this one, how many non-zero rows are there? So all the 3 are non-zero rows. So the last row contains 0 but also contains a non-zero element. So this is also a non-zero row. So here the rank of A is 3. In problem B, B is a matrix. Again, it is a 3 cross 3 matrix. This is also in echelon form. So in this problem, the last row, row number 3 is 0 row. All the elements are zeros. And there are 2 non-zero rows. So the rank of this matrix B is 2. Consider another matrix. This is 4 cross 3 matrix. And 2 of its rows are zeros. Here also there are 2 non-zero rows. And so the rank of this matrix is 2. To know more about echelon form, please follow the pin here. We'll go to problem number 2. Find the rank of the matrix by row reduction method. That means with the help of row reduction echelon form, we want to find the rank of the given matrix. So already we have studied how to do row reduction method. So in this one, first we want to make the first row, second column and third column elements. That means these two elements to be 0. So first take the given matrix. We do elementary row operations. And here R1 is interchanged to R3. So the idea here is in row 3, first column element, this value is -1. So I wish to take this one as the first row so that it is easy for me to do calculation. A lot of things about this one we have studied in our earlier videos, and in the description I have given the link to how to transform a given matrix into its echelon form. So here R1 is replaced by R3. Next, I want to make these two elements to be 0, and what rule I am going to follow, the same I will follow for the two rows. So row 2 is replaced by row 2 plus 2 times row 1. The same way row 3 is replaced by row 3 plus 3 times row 1. When I do this one, I'll get a matrix in such a way that the first column except the first row element, all the other two values are zeros. The same rule I have changed row number 2 and row number 3. Now I want to make this minus 2 to become 0 with the help of row 2. Please note that with the help of row 1 we cannot bring it to 0. Why? Because if we can bring also, then this 0 becomes non-zero. So to avoid that one, I wish to take only row 2. So the last matrix in the previous page, same thing is here. So from this one we want to apply. Yes. So row 3 is replaced by row 3 minus 2 times row 2. If I use this rule, I'll get another matrix. And now just think over this. Can you make this 24 to become 0 with the help of row 2? Definitely with the help of row 1 we cannot able to make. With the help of row 2 also the same logic. If we make this 24 to become 0, then this place will not become 0. So that is the reason we cannot able to proceed further, and this is in the row echelon form. So this is the row echelon form, and the determinant of matrix by taking the first 3 columns is 24. One simple method to find is, so here the dimension is 3 cross 4. So the maximum matrix we are getting is 3 cross 3. So we want to find a 3 cross 3 for which the determinant value is non-zero. So the easy way to calculate is always take the one with more number of zeros so that the calculation is easy. If I take columns 1, 2 and 3, this is a triangular matrix. Okay, so in this case, if I multiply the principal diagonal elements, I will get the determinant value. That means minus 1 multiplication minus 1 multiplication 24. The answer is 24, which is not equal to 0. But I don't know why I am doing all these things. This is not at all required. Why? Because already this is in row echelon form. If this is in row echelon form, then I want to just check the number of non-zero rows. The first one is non-zero obviously. The second one is also non-zero because of non-zero values are there. The third row is also non-zero row. And hence all the 3 rows are non-zero rows, and that is the reason the rank of this matrix is 3. One more problem we will solve. Find the rank of the matrix A, which is equal to, and this is a 4 cross 3 matrix, by reducing to row echelon form. First take the given matrix. So here the pivot element is already 1. With the help of this one we can make the other 3 elements of the same row to become 0. So row 2 is replaced by row 2 minus 3 times row 1. But for row 3 and row 4 it is easy. Direct subtraction is enough. When we apply these transformations, we'll get the 3 values to become 0. Next what we want to do, we want to make this place to become 0. Even if I look at here, I can say one thing here, it is minus 4 and plus 4. So take 4 outside, this becomes minus 1, or even if I take minus 4 outside, this will become plus 1 and 1. So I will interchange so that this will go to here, means I can easily make these two values to become 0. Yes, I am doing this one. Row 3 is replaced by minus 1 by 4, row 3. So now I will interchange row 2 and row 3. Yes. Now with the help of this one, I can make these two places to become 0. So row 3 is transformed to row 3 plus 7 into R2. Row 4 is replaced by row 4 plus 3 into row 2. So I will get a new matrix in which there are so many zeros. And now I am trying to make this value, the last value, to become 0. So with the help of, definitely with the help of R3 only it is possible. So even we can do one thing, here it is minus 2. We can divide this one by either 2 or minus 2. So that this becomes 1 or minus 1, depends upon what number we are dividing. Here what I have done, row 4 is replaced by row 4 minus 1 by 2 row 3. That means directly I am converting this minus 1 to become 0 to avoid the number of steps only. See here, now this value also becomes 0. So now whether we can able to make this minus 2 to become 0? Definitely not. Because with the help of row 2, if you are trying to make this value to become 0 means, then this 0 will become non-zero element. So then it will affect the echelon form. And now this is in echelon form, row echelon form. Okay. So now when this is the row echelon form, we want to see how many non-zero rows are there. So only one row with 0 elements and the other 3 rows are non-zero rows. And that is the reason the rank of the given matrix is 3. There is a point to think. To find the rank of a matrix, why should we need to find the number of non-zero rows? Why not we find the non-zero columns? Find the answer, put it in the comment box. Thanks for watching this video. This is a video by See Through Max. Subscribe to get more number of videos like this one and click the bell icon for regular updates. See you in the next video.